Okay, so in this last part of this lecture, we're going to be looking at how to graph e to the power of x and just in general exponential functions. So if you have the e in the base, there's a special key for that on your keyboard. I'll tell you where to find the key first, and then we'll go ahead and take a look at how to use this. If you take a look at your keyboard, there's a key for the number 4. Directly next to it, there's a key that says ln. And in blue or yellow, depending on your calculator model, it says e to the power of x right there. So because it's in blue or yellow, in order to get it, you have to ask the calculator first. The command is going to be to first do second, and then click the ln key. And when you do that, on your screen, you will end up seeing e with an exponent basically, okay? And so it's gonna say e, and then you type in whatever number or letter you want, you close the parentheses, and then just click enter. So that's pretty much it. So like for the first one, I'm gonna be putting -4, then clicking enter, and if I did that, I would end up with 0. So e to the power of -4 is gonna be, roughly speaking, 0.018. It's something super small, but that's pretty much how it's gonna work. Okay, so I'll give you a second here to pause the video and fill out the rest of these numbers in, and let's see if we get matching solutions. Okay, did you get the same numbers I did? And as you can see, hopefully, it seems like all these numbers are very small, and I don't know if you noticed already or not, but these numbers down here look like they're gonna be very big. Okay, as a matter of fact, when you plug in 4, you already have 54 point something. So keep in mind that the base in this problem is the base e, and e is, roughly speaking, 2.7, which is more than 1. So I expect the graph to kind of look like this. I expect it to start very small and just kind of like go up as usual. So that's the graph that we're expecting from the start of the section, okay? And that's all because the 2.7 is more than 1, pretty much, okay? So let's go ahead and take all this and put it on the XY plane and see what that looks like, okay? So as usual, we said earlier that your graph is always gonna pass through the point 0, 1, and you can confirm that by looking at the table that we just made. The table has 0 and 1, like we said, it would always do. And it always will have the point 1 comma the base. So the base is 2.7 roughly, it's e. So it's always gonna pass through the point 1 comma base. In this case, the base is e. And you can confirm that by looking at the second row right here. So these are the 2 rows that are super special basically, okay? No matter what, your graph is gonna always pass through these 2 points, 0 comma 1 and 1 comma the base. Okay, and that's what I'm seeing from this graph over here. Okay, so far it looks like they're both working. And if you want additional points for more accuracy, you can use other points. Like for example, when x was 2, the y was 7 point something. So you know, it's kind of like roughly right there. This is the point 2 comma e squared, which is roughly 7 point whatever. When x was 3, I have 20. It's not gonna fit on this grid, it's way too high. On the other hand, when x was, for example, -1, you would see that the y is 0.36. So when x is -1, the y is 0 point something. So it's like kind of small. And again, it seems like the graph is gonna do the same usual shape. Okay, and keep in mind again that the x-axis is a horizontal asymptote. The y equal to 0 is HA, which means don't cross this line when you graph the thing. Okay. So make it kind of horizontal, stable, and then all of a sudden it skyrockets, shoots up, and then that's the general idea of the graph.